I'm Saishriya.
Welcome to Agora Math Circle. Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel.
This is Junior Intermediate Session 7 lecture notes, and the topic is decimals. Now, in decimals, there's something called the number system. In the number system, there are natural numbers, which are basically counting numbers. They start from 1 and go on and on and on. An example is 1, 2, and 3. Number 2, whole numbers. Whole numbers are counting numbers, but they also include 0. So there are 0, 1, 2, 3, 4, and 5. Number 3 are integers. Integers are positive numbers as well as negative numbers. Positive numbers are numbers that are greater than 0, while negative numbers are numbers that are less than 0. 4. Rational numbers / fractions are basically parts of the whole numbers. So they include numbers like fractions, roots, and decimals, obviously, and exponents.
So one thing that you notice in all of these types of numbers is that they use the digits 0 through 9. So whether it's a fraction or a decimal, or it's a negative or positive integer, they all use the digits 0 through 9. So now let's learn about base 10 with an example. So the example includes the number 123. So 123 is made up of 3 ones, which is 3, 2 tens, which is 20, and 100, which is 100. So you would write this like this: 1 times 100 plus 2 times 10, which is 20, plus 3 times 1, which is 3. So each place gets 10 times bigger when you go from right to left. So 3 times 1, you're multiplying by 1. And 2 times 10, you're multiplying by 10. And 1 times 10 is 10. So this is 10 times bigger. And then over here, you're multiplying by 100, which 10 times 10 is equal to 100. So it gets 10 times bigger when you go from right to left. So that's the base 10. We know that for certain type of numbers, each place gets 10 times bigger when going from left to right. This applies to whole numbers, natural numbers, and integers, but it does not apply to fractions and rational numbers. This is because fractions and rational numbers are less than 1. But for fractions and rational numbers, we have something called the decimal. So the decimal is a way of writing in numbers where each digit represents a power of 10. It also needs a decimal point to separate the whole numbers from the fractions of a whole number. To understand decimals a bit better, let's look at this example right here. 428 point, which is the decimal point, 1, 2. So, starting off, let's go with the highest value, which is 100. So 4 is in the hundreds place, 2 is in the tens place, and 8 is in the ones place. Then there's a decimal point to separate the whole numbers from the fractions. So after the decimal point, there's the tens place, or 1 over 10. So the tens place is 1 in this case. And after that, there's the hundreds place, which is 2. Also, in decimals, from the decimal point, when you're going left, it would be multiplied by 10. The place would be multiplied by 10. But then when you're going right from the decimal point, it would be divided by 10. As you can see, 1/10 is greater than 1 over 100. So it's divided by 10.
Now let's learn how to read a decimal. Step 1, read the whole number normally. Step 2, say "and" for the decimal. Step 3, read the number after the decimal normally. Step 4, add in the place value of the last digit. Like this, let's go ahead and try to read the example 2.72. Step 1, read the whole number normally. So we can forget about the decimals here, and we could just say 2. Say "and" for the decimal. So we say 2 and. Let's go ahead and pretend that the decimal point actually means "and." I like to think of it as if we're reading a sentence here. So it's 2 and, read the number after the decimal normally, 2 and 72. But that doesn't sound right yet. So, step 4, add in the place value of the last digit. Well, we know that 7 is in the tens place, so 2 is in the hundreds place. So it's 2 and 72 hundredths.
Okay, now let's learn how to add decimals. To add decimals, you first need to write the problem with the decimal points in line. That means you need to align the decimal points. After that, you need to add normally without looking at the decimal point. So just add normally. After that, drop the decimal point. So add the decimal point back in. And after that, you need to remove any zeros at the end of the decimal. Knowing this, let's do the example problem given to us. Add 17.58 plus 4.32. So first we need to write the problem with the decimal points in line. So just align the decimal points. Do not look at the decimal point and just add normally. So 8 plus 2 is 10, carry the 1, and you would get 1 plus 5 is 6, 6 plus 3 is 9. Do not look at the decimal point and continue adding. 7 plus 4 is 1, carry the 1, and you would get 2190. But after that, you need to put the decimal point back in. So you need to put the decimal point where it aligns, which is right over here. So after that, you need to remove any zeros at the end of the decimal. So is there any extra zeros in this decimal? Yes, there's an extra 0 right after 9. So we can just remove that. So 17.58 plus 4.32 is equal to 21.9, or 21 and 9 tenths. After that, let's go on to subtracting decimals. So subtracting decimals, you need to write the problem with the decimal point in the line, same as above, and then you need to subtract normally without looking at the decimal point. Then you need to drop the decimal point and remove any of the zeros at the end of the decimal. So let's go ahead and subtract this problem right here. 17.58 minus 4.32. So let's write it down and align the decimal points. So we've aligned the decimal points, and we're just going to regularly subtract without looking at the decimal point at all. So 8 minus 2 is 6, 5 minus 3 is 2, 7 minus 4 is 3, and 1 minus 0 is just 1. So after that, we need to add the decimal point back in or drop the decimal point. So we would align it right over here. And there isn't any extra zeros at the end of the decimal. So the answer would just be 13.26. If you understood this, try the practice problems in the lecture notes.
Now let's learn about multiplying decimals. Let's read the steps. Step 1. Line up the numbers ignoring the decimal. Step 2. Multiply normally. So in step 2, we're also forgetting about the decimal. Step 3. Count and add the number of digits behind the decimal for both of the numbers. Step 4. Place the decimal in front of the same number of digits you counted and added. Knowing this, let's go ahead and try to do the example problem given to us. So let's read it. Jess bought 7.1 pounds of rice, which is $1.50 per pound. How much did the rice cost? So let's go ahead and try to solve this problem. Well, we know that Jess bought 7.1 pounds of rice, and that's important. So I have already underlined it here. So since we know that Jess bought 7.1 pounds, why don't we write the number 7.1? And we know that 1 pound of rice costs $1.50. So to find out how much you has to pay for a 7.1 pounds of rice, you have to multiply 7.1 and 1.50. So you multiply by $1.50. So now let's go ahead and use the steps to learn how to multiply properly. So let's go ahead and try. So we first have to line up the numbers ignoring the decimal. So I'm just going to erase the decimal for now so you guys remember that it's not there. So let's go ahead and multiply 150 and 71. I like to put the number with the most number of digits at the top so it's easier for me to multiply. And then I put the number that has less digits than the first one on the bottom. I find this very easier, but if you guys have a different way of doing this, you guys can go ahead and do it. So we know that 0 times 1 is 0, 5 times 1 is 5, and 1 times 1 is 1. So we're doing 150 times 1. So we bring down the 0 since we're doing 150 times 70, and we do 0 times 7 is 0, 5 times 7 is 35. We put the 5 down and we bring the 3 up, And then we do 1 times 7, which is 7, plus 3, which is 10. And when we add, we get 0 plus 0, 5 plus 5. 1 plus 5 is 6, and there's nothing to add here. So we get 10,650. So we know that the answer is 10,650 here. So after we've multiplied normally, let's go ahead and go on to step 3. Count and add the number of digits behind the decimal for both of the numbers. So I'm going to go ahead and put the decimal back, and we have to find out how many digits there are behind the decimal. So if this is the decimal here, we have to find out how many times you move one place to the right, or how many times you move a certain number of places to the right to get to the end. So in this case, we only move one place to the right to get to the end. So that's 1. But in 1.50, we move twice. See? 1, 2. So that's 2 places. So what we do is we add the number of digits we had for both of them decimals. So after you add them, you place the decimal in front of the same number of digits you counted. So we counted what? 3. So we know that 3 is the number of digits you have to count before putting in the decimal. So we actually go backwards when we're trying to do this. So it's 1, 2, 3. So the decimal goes here. So once we put the decimal here, we can forget about the 0 that's here. So the actual answer is $10.65. So that's the answer for this problem.
Okay, now let's learn how to divide decimals. Now there are 2 ways to divide decimals. You use the first way if there aren't any decimals in the divisor. Now here are the steps. First, you need to line up the problem normally. Then you need to divide normally. And last but not least, you need to push the decimal up and continue dividing. Also, remember that you can add as many zeros as needed. Now, knowing this, let's do an example problem. Tara walked 5.80 miles in 4 days. How much did she walk in 1 day? So we know that she walked 5.80 miles in 4 days. So what we're solving for is 5.80 divided by 4. So let's just put this up in the algorithm. 5.80 divided by 4. Now how much does 4 go into itself to get 5? 1 time. So 1 times 4 is 4, and you would subtract normally. Then you would bring down the 8. Now how much does 4 go into itself to get 18? 4 times, since 4 times 4 is 16. So 4 times 4 is 16. Then you would subtract and bring the 0 down. So you would get 20 divided by 4, which is 5. So we know that 580 divided by 4 is 145. But then we still didn't put the decimal in. So we need to scoot the decimal up and put the decimal right there. So we know that this is equal to 1.45. So Tara walked 1.45 miles in 1 day. Now let's move on to decimals in the divisor. So if there are decimals in the divisor and you want to divide, what you need to do is first scoot the decimal to the right until it has reached its end. Then scoot the decimal the same number of digits as the dividend. Then you need to line up the decimals and solve normally. Then scoot the decimal up and finish dividing. Now that we know this, let's solve this problem right here. Now the first thing that we need to do is scoot the decimal to the right until it has reached the end. So we're going to be looking at the divisor, which is 1.2. So we need to scoot until it gets to the end. So you can only scoot 1 time until it gets to the end. So we also need to do that to the dividend. So scoot it 1 time until it gets to the end. So really, you're going to be solving for 108 divided by 12. And you already know what that is. 108 divided by 12 is just 9. So 10.8 divided by 1.2 is just 9.
Now let's look at the conversions between fractions to decimals and comparing and ordering decimals. So there's 2 ways between conversions and fractions and decimals. You can go fractions to decimals, or you can go decimals to fractions. We're going to first start out with fractions to decimals. So let's go ahead and read the directions. So divide the numerator by the denominator. Well, we know that 3 is the numerator and 5 is the denominator. So when it says divide the numerator by the denominator, we know that the 3, which is the numerator, has to go inside and the denominator has to go outside. Well, we know that nothing multiplied by 5 can get to 3, so it's obviously a 0. And we know that 0 times 5 is 0, and after we subtract, we still get 3. But you want to add a 0 in so you can multiply by 5 to get to a number. When we add a 0, we usually have to add a decimal point in. So after you do that, you can divide normally. There's no changes after that. Well, we know that 6 times 5 is 30, so that's obviously the answer. And make sure to subtract. And we get 0, so we know that 0.6 is the answer. So 3/5 converted to a decimal is 0.6. Now let's go ahead and move on to decimals to fractions. Let's read the steps. Put the decimal as the numerator and have the denominator be a power of 10. And the number of zeros is the number of digits after the decimal. If you guys don't understand the procedures yet, I will explain it further on more. Well, let's first go ahead and try to convert this decimal to a fraction. Convert 0.5 to a fraction. Well, we know that what we need to do is put the decimal as the numerator. So, well, we know that 5 is basically the decimal number here. So 5 will be the numerator. But what's the denominator? The denominator is the power of 10. And to find out which power of 10 it is, all you need to do is find out how many times you have to move one place to the right until you get to the end of the decimal number. Well, in this case, we only move once. And when you're moving once, you're basically multiplying by 10 ones. So that means the base has to be 10, since you only multiply by 10 once. So 5/10 is the answer. But we can still simplify this fraction. Well, we know that in 10, 5 is a multiple of 10, and 5 is obviously a multiple of 5 too. So we can just divide by 5, since that's the greatest multiple. And we get 1/2. So 1/2 is the answer. And now let's move on to comparing and ordering decimals. So look at the numbers in the highest place value and compare. Well, we need to compare 3.752, 2.905, and 3.5256 from least to greatest. So to do this, we first have to look at the whole numbers here. So there are 2 3s and 1 2. We know that 2 is less than 3, so that's the least number. So we can write that down here, 2.905. But what comes next? Well, we know that the whole numbers are alike, so we have to look at the number after that. So we're basically now comparing 7 and 2. Which is greater? We obviously know that 7 is greater, so that's at the last. If 3.752 is at the last, then 3.256 is obviously next. So it's 3.256 and 3.752. So that's how you would order it from least to greatest.
Okay, let's look at a practice problem based on what we have learned. What is the sum of the first 2,018 digits after the decimal point of 1/7? So as we notice, it says the decimal point of 1/7. So we need to convert 1/7, which is a fraction, to a decimal. So we need to find the decimal value of 1/7. You would do that by dividing. Now you need to divide 1/7. Now anything times 7 cannot equal to 1. So you add a 0 here and a decimal point so you can continue dividing. And when you add the decimal point, you need to add a 0 right here. Now 1 times 7 is 7, and that's the closest thing. So you need to subtract, which is 3. Then you bring down 0 once again, and 4 times 7 is equal to 28, which is once again the closest thing. Then you would subtract and get 2, and bring down the 0. And you would get a 2, because 2 times 7 is 14, and that is the closest thing. Then you would subtract and get a 6, and bring down the 0. Then you would get an 8, because 8 times 7 is equal to 56, and that is the closest thing. Then you would get a 4 and a 0. You would add a 5, because 5 times 7 is 35, and that is the closest thing. And finally, you would get a 5. And you'd add a 0 right there because 50 divided by 7 is 7, and that is the closest thing. And once again, you would get a 1 remaining. Now, as you have noticed, we started with a 1 right here, and we got this set of digits. So if we ended with a 1 right here, you would continue to have the same number of digits. So this is a repeated decimal, and you would add a line right there. So 1 over 7 is equal to 0.142857, and it's repeated. So we know this. Now we just need to find the sum of the first 2018 digits after the decimal point. So we don't need to look over here. Now, we know that there are 6 digits right here. 1, 2, 3, 4, 5, 6. So we need to do 2018 divided by 6. Now we need to find the sum of all these digits. Now 1 plus 4 is 5, 5 plus 2 is 7, 7 plus 8 is 15, 15 plus 5 is 20, and 20 plus 7 is 27. So the sum of all these digits, which is 1 plus 4 plus 2 plus 8 plus 5 plus 7, is equal to 27. So we need to multiply by 27. So we need to multiply over here, but we can simplify before we do that. As we have noticed, 6 and 27 are both a multiple of 3, so we can divide both of them by 3. Now 6 divided by 3 is 2, and 27 divided by 3 is 9. So now we need to divide 2018 by 2. Now 2 divided by 2 is 1, and you would subtract to get a 0 right here, and you would add a 0. Then you would subtract again and get a 1, and 1 divided by 2 cannot equal anything, so it's a 0 again. Then you would bring down the 8, which is the last digit, and get a 9. So 2018 divided by 2 is equal to 1009. But then you still need to multiply by 9. So 1009 times 9. 9 times 9 is 81. You carry the 8, and 0 times 9 is 0, and you add the 8, and 0 times 9 is 0, and 1 times 9 is 9. So the answer is 9,081. So the sum of the first 2018 digits after the decimal point of 1 over 7 is equal to 9,081.
Now let's look at this example problem. What is 1/3, 2/3, and 3/3 in decimal form? Well, we know that when we convert a fraction to a decimal form, we usually have to divide. So let's go ahead and start with 1/3 when we're dividing. We know that 1 goes inside since it's the numerator and 3 goes outside since it's the denominator. And we also know that nothing times 3 can get to 1, so we basically have to add a 0 here. And when we add a 0 here for the first time, we usually have to add a decimal point. So now we're just going to keep going normally. So what times 3 is the closest number to 10? It's obviously 3. 3 times 3 is 9, which is the closest number to 10 in this case. And we get 1. Have you noticed the pattern? We've come back to 1 again. But are we going to come back again after we multiply this one? Let's see. We can add another 0 here, but we don't have to add a decimal point since that's only for the first time. And we got 3 again. So yes, it is a pattern because we keep going to getting 3. So it's 0.3 replicate, which means that's going to keep going on. So 1 over 3 is equal to 0.33333 on and on and on. Now let's go ahead and go over to 2/3. Well, we can use the same method here, right? We know that 2 over 3 is basically 2 times 1/3. And 1/3 is 0.333 replicate. So why can't we just get 0.66666? Right? So now let's go ahead and go on to 3 over 3. So let's go ahead and use the same method here too. 3 times 1 over 3, which is 0.99999, right? If you guys haven't seen it yet, you guys might think that this is wrong, but it's actually not. This type of problem was actually founded 2,000 years ago, and it's called the Zeno's paradox, which is founded by the Greek philosopher named Zeno. and it's actually known as the culprit, which means that this number can keep going on and on and on and still equal to 1. Let me show you why. Well, we know that 1/3 is equal to 0.333, but we can't round it since it's less than 5, so it's still 0.33. But that's not the case for 2/3, right? Because 2/3 is equal to 0.666, which is greater than 5, so we can round up. So 2/3 can equal to 0.67. And we know that 1/3 plus 2/3 equals 3/3, which is 1, right? So can this go in decimal form too? Let's see. 0.33 plus 0.67 can still equal to 1, which means that this answer is right.
This concludes Junior Intermediate Session 7 lecture notes. Thanks for watching! Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!